Here's your Unit 0 study guide explained. For the first part of the test, you'll have to classify real numbers into their most specific category. The square root of 49. The square root of 49 is equal to 7. 7 is a counting number, which is a natural number. So for the first one, 7 is A, natural. The second number, -3, is a negative whole number. Positive and negative whole numbers are integers. So -3 is C, an integer. Pi. Pi is our most famous irrational number. So for pi, you should have said E, irrational. It's non-terminating and non-repeating. Anytime you have a fraction, it's a ratio or a rational number. So 1 1/2 is rational. The square root of 2. The square root of 2 is not a perfect square. It is a non-terminating, non-repeating decimal. It goes on and on and on. Therefore, it is irrational. Letter E. And 0 is our first whole number. Whole numbers are 0 and up. So for whole number, you should have said, or for 0, you should have said B, whole number. Part 2. Decide whether each of the following numbers is rational or irrational. A, -2 2/5. -2 2/5 could also be written as the ratio -2 1/4, or the fraction -2 1/4. This is a terminating decimal. It stops, so it is rational. 3/4, 3 out of 4. That's a rational number. It's a ratio. Pi. Pi is our most famous irrational number. It is non-terminating and non-repeating. 0. 0 is our first whole numbers, and whole numbers are rational. The square root of 45. When I put the square root of 45 into the calculator, I get a non-terminating, non-repeating decimal. It goes on and on and on and on and on and on and on, and it's just going to keep going. So the square root of 45 is not a perfect square. Therefore, it's irrational. And the last one, this bar right here indicates that it's a repeating decimal. Decimals that repeat or terminate are rational. Part 3. Determine if the following rational numbers are repeating or terminating decimals. 2 out of 6. So 2 divided by 6 is 0.333, and it's going to keep repeating. So a repeating decimal, we would circle repeating. And then part B, 7 divided by 8, or 7/8, equals 0.875. This is a terminating decimal. So again, to do that, you put the numerator divided by the denominator. For part 4, determine the two integers the following irrational numbers would fall between. These are not perfect squares, so we're going to find out the two integers that it falls between. In my calculator, I'm going to use the second function, then look for the x squared button. Then I would put in the value and hit enter. So the square root of 43 is approximately 6.5574, and so on. So now to determine the two integers that it falls between, this is like 6.5 or 6.5. So it would fall between 6 and 7 on a number line. For the square root of 8, I would put in second function, x squared, 8, enter. And the square root of 8 is approximately 2.828 ... So the square root of 8 would fall between the integers of 2 and 3, because 2.8 or $2.82 would fall between 2 and 3 on a number line. Again, the calculator function, second function x squared, and then put the values in. Part 5. Approximate the following irrational numbers to the nearest hundredths place. So I'm, again, accessing those same calculator functions. Second function x squared, and then put in 3 and enter. And you get approximately 1.7320 and so on. Now to go to the hundredths place, that's 2 positions past the decimal. Now we have to decide, do we round it? Does this stay a 3, or does the 2 make it increase? This number has to be 5 or up to round up. So this one will stay 1.73 for the hundredths place. The square root of 32 is also an irrational number. So this one, when I put it in the calculator, goes 5.6568 and so on. Same directions. We're rounding to the hundredths place. So tenths, hundredths, that's 2 places past the decimal. We're going to look behind the hundredths place. We have the number 6. So if it's 5 or greater, it makes the value round up. So this one becomes 5.66 when rounded to the hundredths place. Order these numbers from least to greatest. Now right away my eye is drawn to the negative. Negative is going to be the smallest value, followed by 0. And then I have a little bit of work to do, but I'm thinking that the square root of 18 is going to be the smallest of the square roots, but I want to put that in my calculator and check it. So that is approximately $4.24, or 4.24. So that is going to come next, because I know that the square root of 36 is 6. So I'm going to do that one next. And then it's between these two. So I'm going to put the square root of 52 in my calculator. And the square root of 52 is 7.21. So it's a little bit greater than just plain old 7. So 7 would come next. And then the square root of 52 would be last. Okay, in the last part, we're going to approximate the following numbers and mark them on a number line. So my first step would be to make them all look like normal numbers. Like 5.5, that looks fine. 2 times pi, I want to put that in my calculator and estimate that. And that's approximately 2 times pi is 2 times 3.14, which is about 6.28. 15 over 3, or 15 divided by 3, is 5. Then I want to do the square root of 2, second function x squared 2, and see what that equals. And that's approximately 1.41, like $1.41. Okay, then I want to do the square root of 40, and that's about 632. And then the next one is the cubed root of 27. That means what times what times what is 27, the cubed root. So that's going to be 3, because 3 times 3 times 3 equals 27. To put a cubed root in the calculator, you would put in 3, and then the second function, and then we'd use what's called the caret key. Then 27, and then equals. But it means what to the third power equals 27. And then finally, the square root of 5 is also not a perfect square. And for that one, I would do second function x squared 5. and that is $2.24. Okay, so then I would have to decide what my number line range would be, like from high to low. So my highest value is right here, the square root of 46.32. So I would want to, and my lowest value is 1.14. So I might just number from 1 to 6 or 1 to 7 on my number line. So there I've numbered from 1 to 7 on my number line, and now I'm going to approximate these. So I've put them over to the side so I can just drag and drop them. So the square root of 2 would come first, which is about $1.41. So that would fall about just before the halfway point. The next value, the square root of 5, is 224. So we're going to move that one into position, 224, to be closer to 2 than it would to 3. And I'm going to drop a line right there. Okay, next up would be the square root, or the cubed root of 27. That's exactly 3, so that's right on 3. Okay, next up would be 15, the ratio 15 over 3, which would be exactly 5. Okay, next up would be 5.5, which would fall right between 5 and 6, right at the halfway point. Then 2 pi would come next, followed by the square root of 40, and those are very close, so I'm just going to hover and then show that they're very close to each other.